Hi, my name is Jasmine, and I'll be giving you an example of a STEM education practice where digital technologies were used as an essential tool. I designed this activity for foundation phase students. Aspects of the Australian curriculum will be addressed with this activity. Students will collect, explore, and sort data and use digital technologies to display that data to convey its meaning. My student was sent on a solids, liquids, and gases scavenger hunt and recorded his data on a table, classifying an object as either solid, liquid, or gas.
Okay, you have 5 minutes to record as many solids, liquids, and gases as you can see.
My student learnt about changing states of matter in the second half of the investigation. 5 solids were placed into bowls and their melting times were recorded on a table. In a classroom situation, I would have divided students into groups, as this would make the task more manageable and they would also be able to develop their communication and collaboration skills.
Set up 5 items, which are solids to begin with: ice, chocolates, margarine, butter, and ice cream. We're going to put some warm water in the tray and time how long it takes for each item to melt. Start the timer. Go. How much? Okay, so the chocolate is now melted as well. How long did that take?
9 minutes and 30 seconds.
Sure, it's pretty long, hey?
My student used the Maths is Fun website to design a graph for his 2 sets of data. My student explored the different graph options and selected the most appropriate graph for the data he had collected. He had to choose a graph that organized the data and made it easy to analyze. He made a bar graph to compare melting times and a pie graph to show the relative sample sizes of solids, liquids, and gases.
Okay, so using the data that we got from our experiments, we need to go onto the site and you're going to choose the best graph for your data. Okay.
I chose a bar graph.
You chose a bar graph. Okay, that's good. So put your values in and let's see if it makes a nice readable graph.
Although Kelly and Knowles' pulley system was intended for secondary education, I think that in this activity many STEM connections were made. The student used science inquiry and elements of the engineering design process to conduct the investigation and collect the necessary data to complete the task. He also learnt about states of matter and the effects of heating and cooling on materials. The main learning objective was to collect data and present it on a graph. My student identified that need and used the available technology to design a graph that was easy to analyze. Mathematical thinking and technology literacy were developed as the student collected and classified his data and used digital technologies to present it creatively. By choosing the most appropriate graph for the collected data, he was able to appreciate the usefulness of the different data displays and make the connection between mathematics and the real world. According to Sparrow's definition of digital fluencies, curiosity fluency was developed through the investigation and exploration of the Maths is Fun program. My student managed to collect the data that he needed by conducting an experiment, and he created a useful graph. Communication fluency was developed as my student analyzed his graph and discussed its meaning. He selected graphs that were easy to read, which indicated that he understood the relationship between the variables. He developed data fluency as he explored the data processing capabilities of the program, and creation fluency as he made his graph using the Math is Fun program. He was motivated to learn programming skills to create his own data processing program in the future. Using the WHO workflow, digital technologies enhanced the learning experience. The main objective of the activity was to improve students' fluency in collecting, capturing, and displaying data. I chose a simple design digital technology tool because understanding and analyzing data is a difficult concept for a Year 2 student. The website was easy to use and gave my student the opportunity to explore all the graphs available before selecting the most appropriate one. Without the technology tools, my student would have to draw his graph, which would not be as accurate, and he would not have had the chance to explore all the ways that data can be displayed. Digital technologies allowed my student to present his data visually, and the learning objectives were met. When applying the activity theory, I identified a contradiction between the student and the digital technology tools. Initially, my student had difficulty using the website, as it was not something he had used before. But after some time, he became more confident and was able to make an accurate graph that was easy to analyze. The contradiction between the learning activity and myself was due to my own expectations of my student's knowledge about graphs. I expected him to know what information was needed to complete his graph, but I had to prompt him at first. In a classroom situation with younger students, some background information on graphs and their use would have to be given. Here is the contradiction between myself and the learning objective and my student and the digital technology tools. By planning more activities like this, students' digital fluencies will improve. Students could regularly collect data in class or at home. They could conduct a survey at home or in class. Students should be encouraged to make a graph every time they collect data and present it to their peers. Data that is presented visually is easier to understand, and students will become more adept at identifying patterns and finding correlations, which is an important skill to develop. Thank you.